Okay, last question, question 10, electrostatics. So key topic there for our triple science. So you're pretty guaranteed to get one of these because it's that focus on what is triple science. So question about static electricity. Student's got a rubber balloon tied to a piece of cotton thread. Give one way that we could give the balloon electrostatic charge. So crucial part, let's get an insulator. Let's rub that balloon and let's move electrons from one place to another. So we're going to charge by friction. So please work. Yes, so we're going to charge by friction. We're going to rub the balloon with an insulator. That's a key word. So for example, a cloth. And then I could even add in there, this will move electrons from and to whichever way we want to go. It doesn't state whether we want a negative or positive charge. But the crucial part is we're going to charge by friction and then describe it. Which of these sentences explain overall the balloon has a negative charge? So if we now imagine this now, there's our balloon, there is our cloth, and why is it negative? I still have some positives, but why has it got a net negative? Well, clearly that has come because electrons have moved from the cloth to the balloon. So negative charge has been added to the balloon. And we've learnt that in solids, we can't move that positive charge. That's the protons inside the nucleus. But we can move these electrons that are miles away from the nucleus. Student charges another balloon on a long thread, and that's really important for this question. It says, explain how the student can show that the two balloons have the same type of charge. So I've got a balloon, I've got a balloon. And why is it saying that we've got to have it on a thread? If I held the balloon in my hand, there's the hand, and then if I attach that to my body, that body's on the floor, draw a pair of legs, I know that's ropey, but if I'm just carrying the balloons around, the negative charge is going to be grounded to the floor. If I now keep that balloon isolated in the sky, it will maintain its charge for longer. So that's the idea of this piece of string. They've tried to emphasize it in the question, and it's explicit in the mark scheme. So it's quite important. So we just got this idea, we don't want to discharge the balloon. So bring the balloons together on the strings so they're not discharged. The balloons should repel each other, and then it's that same old message every time because our same charges will repel. All right. Going on to the next bit. Figure 26 shows a plastic block with a metal disc and an insulating handle. So there's a metal disc. Here's some sort of plastic, so plastic metal. And here we've got a plastic block. The student uses the insulating handle to hold the metal disc above the plastic block. So we can see the example here. All right. And which of those show how the charge is distributed on the metal disc? Okay. So it just says here, the top surface of the plastic block has a negative charge. So we can see that there. So what's going to happen is, if I just sketch it here, we know that's negative. I've got an insulating handle, so I don't remove the charge. There's my metal disc. And at the start, it's neutral. But what's going to happen is, as we bring this close, the electrons are going to be repelled backwards into that insulating handle, and because it's an insulator, it'll hold that charge for a while, and then the front of the disc is going to come positive, and there'll be a slight force of attraction between the two. But it's this idea that we're charging by induction. So that's using a known charge to either attract or repel electrons on the front of a surface. So B. And we can see that there. We've pushed the negative charge to the back of the metal. All right. And that's where it's going to stay. As long as it's grounded. As long as it's insulated in the air. The student keeps holding the metal disc above the charged plastic block and taps the metal disc with a finger. This earths the metal disc for a short time. So what's going to happen is, what does that mean if I earth it? It just we're moving electrons around, so we're just going to remove negative charge. So explain why the disc now has an overall positive charge. Electrons will flow from the disc to the ground. And that's why it's got a positive charge. We've actually allowed the electrons to flow to the ground. And the last part here, we've got a positive charge and a negative charge. I've taught you POUT and NIN. And we know that this is going to set up a uniform electric field. So always stick to just drawing 3 lines, one on each side and one bang in the middle. And we know it's going to go out from the positive and into the negative. So that's that there. We can see it going from positive to negative, 3 lines, with a 3 lines with the centre one being equidistant from the others. And there we go, that's that paper done.